Hello there, welcome to another video, and in this video we're going to be talking about the question that is reach a number on LeetCode. So as you can see that it has been given that you're standing at a position 0 on an infinite number line. There is a destination at position target. So you can make some number of moves, num moves, so that on each move you can either move left or right. And during the ith move, starting from I is equal to 1 to I is equal to num moves, you can take I steps in the chosen direction. So given the target, we have to return the minimum number of moves that is needed to reach the destination. So as you can see in this example over here, the target is 2, and on the first move we can move only one step. So we step from 0 to 1. Then on the second move we can make 2 steps. So we step from 1 to -1. On the third move we step again from -1 to 2, which is our target. So that's how we reach the target. So here let's design our approach for this question. So as you know that we have been given the initial position as 0. Okay, now there can be initially two cases. Okay, so the first case is suppose you're moving like from your source to the right. Okay, like first you move with one step, then you move with 2 steps, obviously, because in the second move you can only move with 2 steps, right? So you do like this. Suppose your target lies in this path itself, in this path that you're moving, like 1, difference 1, and then difference 2, and then difference 3. Suppose your target lies on this path itself. Your target is 1 or 3 or 6 or something like that falls in this path. In that case, you know that you don't need any additional steps. You can simply just keep on moving to the right, like this. You just keep on moving to the right, and how many ever right moves that you make, that will be your final answer, right? So you don't need to make any additional steps. Now, what is the second case? Okay, second case is basically that if your target does not fall on this path. So suppose your target is 5. Okay, your target is 5. So once we move here by 1 step, then we move here by 2 steps, then we move here by 3 steps. So we reach 6. Okay, but our target is 5. So in this case, when our target does not fall on the path that we are following, in this case what we do is we just consider the number that we reach in this path that is just above 5. Okay, so here in this path we reach the number 6 that is just above 5. Okay, so this we set as our pause. Okay, we take this position and we store this. Now what we do is we find the difference between this pause and t. Okay, we find the difference between this pause and t. So if this difference is even and if this difference is odd, will be categorized into 2 different conditions. So if this difference is even, now in this case, if this difference is even, it is 100% sure that you will be able to reach this target that is 5 with this exact number of steps itself in which you have reached this pause. So like suppose here we have reached this 6. We have reached 6 using 3 steps, right? 3 moves, sorry. So you can also reach 5 using the exact number of moves, that is 3. Okay, how will you do that? In order to do this, we just need to flip any one move earlier in the path. And by any one move, I don't mean that you can like literally you can flip any move. You just need to flip you have to choose one suitable move and you have to flip that from left to right. Like suppose here we have been moving right, so we can just flip it and make it left, so that the next step again we can go it in the same direction itself. So that's how we do. So in order to reach the target when this diff is even, we just need to flip any one move earlier in the path. Okay, how are we going to do that? Okay, let's just see this. So suppose here our target is 4. Okay, suppose our target is 4, because with 5 the diff will not come as even. With 5 the diff will come as odd, that is 1. Suppose our target is 4. Okay, if our target is 4, the diff that we get is equal to 6 minus 4 is equal to 2, that is even. Okay, now we for sure you can say that this this target that is 4 can also be reached by the exact number of steps by which we reached 6. That was the 6 is basically the position which lies in the path and is just above 4. That is our target. So how are we going to do that? Suppose that here we instead of going from 0 to 1 in the right direction, we go from 0 to -1 in the left direction. Now, as per the question, we can move in either left or right direction at any point of time. So suppose we go one step to the left. So we flipped this step, right? This right step that we were taking, we flipped this to the left, okay? We flipped this to the left. Now we go left. From -1 again, we just keep on following the same direction, that is right side, to the right side. So -1 to 1, it will go right in 2 steps, because in the second move we can obviously go only to 2 steps. So from 1 again, it goes to 3 steps, 1 2 3, that is, it reaches 4, and 4 was our target, right? So it is this, you can try out this with any condition, like any target, and which satisfies this specific condition, that the number that falls in the path, difference between that number and this target is equal to even. If this is even, then you can always just flip one move in the path earlier, and you can reach that specific target itself in the same number of moves. Okay, so that's done. Now what if this difference now is odd? Okay, what if this difference now is odd? So by that I mean, suppose our target is 5. Okay, suppose our target is 5. So I go from 0 to 1, 1 to 3, 3 to 6, right? These are the moves that I do and the steps that I take. So this is 1. Okay, this is 1. So these are the moves that I do and the steps that I take. So I go from 0 to 1, 1 to 3, 3 to 6. Now suppose my target is 5. So my pose is now at 6, right? Now what is my difference? My difference that I find out is pose minus target is equal to 6 minus 5 is equal to 1. And what is 1? 1 is odd number. If 1 is odd number, we have to check for the last move steps. Last move number of steps. Okay, what were the number of steps in the last move? So as we can see here, in the last move we have had 3 number of steps, right? Now we have to check if this is odd or even. So see, if the last in the last move number of steps were odd, okay, like here number of steps were 3, right? That is odd. From 3 to 6, the move that we took, the number of steps was 3, that is odd. Now since from by going from 6 to the target, in order to go from 6 to the target, we need some additional steps that may be in the right direction or maybe in the left direction. So if we need that, we need to be assured that whether like whatever step we take, whatever move we take in whichever direction we take, whether that results in an even difference or an odd difference. So suppose here my last step was odd, right? So if my last step was odd, then my next step is always going to be even. Why is that? Here in this question it has been given, right, that for the ith move I will have I steps to move, right? So for the third move I have moved here 3 steps. So for the fourth move that is next, I have to move 4 steps. And according to the number system, after every odd number there will always come an even number. After 3 that is odd, there will always come an even number, that is 4. So after 3 number of steps, I will always have to cover 4 number of steps. So from 6 I can go ahead by taking 4 number of steps to 10. So now my final position is 10, right? Now again I'll check if my pose minus t is odd or even. So my pose minus t now is 10 minus 5, that is 5. So it is again odd. But notice that last step that I took was my 4th move, right? Last move that I took was my 4th move. So I had an even number of steps there, since 4 was even. Next step I will take will again be an odd, right? It will again be an odd, right? So once I do that, right, now you should notice this, that since difference over here, this is the difference and this is the additional step that we took, okay? So if the difference is odd, as we know, this condition only itself is for the difference being odd, and if the additional steps is also odd, right, odd plus odd will always produce even number, right? This is general rule. And odd plus even will produce odd number, general rule. As in the last step that we saw, 3 was odd number, right? So when we moved from 6 to 10, it produced odd plus even, 3 plus 4, here the difference was 1. So 1 plus 4, it produced a total difference of 5 to, from 5 to 10 as 5. That is odd. So when we did odd plus even, it produced an odd number, right? But again, one more step if we take, so now if it is odd and I do odd again, right? Because as I said, after the fourth move, that is the fifth move. So after, like, if after one odd number there is one even number, if and then alternatively the next number will also again be odd, right? It's like odd even like that in the number system, right? So that's what we need to do. Here we know that the next step that we will take, it is obviously going to produce an odd number of steps. So when we add that odd plus odd, it's going to be even. So we know that if since our aim here, as I said you, that if we have an even difference in between the pause and the target, only then we would be able to reach the target by flipping any one of the moves earlier in the path, right? So our aim is basically to make this diff as even, right? So we will do the minimum number of steps that is needed to make this diff even, right? So when I once I did this, right, when I moved it from 6 to 10, when I moved pause from 6 to 10, I took one more step. So my difference now was 5. So I took one step there, but my difference is still odd. So my aim will be to shift this odd to even. So I'll take one more step, right? When I take one more step, it will be again added with an odd number, so it will become even only. The difference will be even. When it becomes even, our aim is fulfilled. So we successfully fulfilled our aim with 2 number of additional steps, right? We did 2 number of additional steps and we successfully achieved our target. That is to make the difference between pause and target as even. As you can see in this example also, from 10, if I take one more step in the left direction, now I didn't mention whether you have to take the move in the left direction or the right direction. You can take it in any, like as per the example that you have, you can take it. So here, if I take the move to the left, the next move is going to be worth 5 steps, right? The last move was worth 4 steps. Next move will be worth 5 steps. So I will come back to 5, which is my target. Coincidentally here, my pause and target match, but maybe somewhere pause and target won't match. But your pause minus target, if it is even, right? The diff, that is pause minus target, if it is even, we have to accept the fact, because I have proved you it, right, earlier in this video. We have to accept this fact that if the difference between position and the target is even, we are 100% sure to reach the target by flipping one step before in the path, right? So that is for sure. So we have successfully achieved the target. So let's summarize all the things, all the branches of this question. First of all, what we did is we checked if the target lies in the path, like suppose from 0 I move to 1, from 1 I move to 3, from 3 I move to 6, my difference of 1, difference of 2, difference of 3, like this I moved. So if target is any one of these numbers, in that case I won't have to worry, no additional steps. What if my target does not lie in the path? Here's where I need to take additional steps. Again, here, suppose my target is 5. So I will always have to choose, if this is my target, I will have to choose, I will follow this path and I will choose the number that is just greater number in the path, just greater than my target. I have to choose, okay? Once I choose that, I will set that as suppose pause. Now I will find the difference between that position and target, okay? This difference I will categorize again into odd and even. I have proved it to you earlier. If this difference is even, we again need no additional steps, okay? No additional steps. But if this difference is odd, we need to check for what? We need to check the last move steps, the number of steps that is taken in the last move, right? So we have to check if this last move steps is odd and if last move steps is even. If the last move steps is odd, as we discussed, we have to take 2 additional steps. And if this last move steps is even, we have to take only 1 additional steps. I also have explained you the logic of why this is happening, why odd and odd add, when we add odd and odd number, it becomes even. When we add odd and even number, it becomes odd number again. So I have explained you that earlier in this video. So if you have not understood, kindly go rewind and go watch that part. So this is basically our flow chart. So now what we're going to do is we're going to write the code for this, okay? And one more thing I would like to tell you, okay, don't get confused for negative targets. If you have been given with negative targets, suppose here I have been given the target as -3, okay, -3. So have you noticed something? If I've been given the target as 3, suppose, so I do this path, right? I go from 0 to 1 and then from 1 to 3, right? This is my path. I can, even if I have been given the target of -3, I can do one simple trick in order to get the target of, okay, get the steps for -3. That is, just get the mirror image of this path. -1, I go one step over here, and from here again I go 2 steps. 1 here, also 1, 2, right? I reach -3. So this way, this mirror image rule states that whatever number I have been given, if it is negative also, I can convert it into its positive form. I can find the minimum number of steps that is required to reach its positive form, and it will be the exact same result for its negative form also. Okay, so that's done. Given that, we're going to do this now. One more thing, how are we going to find, like, if the target doesn't lie in the path that we have stated over here, how are we going to find that pose that I showed you? How are we going to find that pose that is just the number that is just greater than target? How do we do that? We do that using binary search technique. Okay, we do that using binary search technique. How do we do that? Now suppose we set our targets. We will basically have one low and one high variable, that is one lower limit and one higher limit. This both limits will be the number of the number of the number of moves that we take. Okay, so this low will be 1 and high will be target. Okay, suppose we take this low as 1 and high as target. So done. So now what we're going to do is, at every step of binary search, we have 3 points. One is this lower point, mid point, and higher point, right? So our lower point is 1, our mid point is 1 plus target divided by 2, and then our higher point is target itself. So suppose we check that using this mid number of moves. Okay, one more thing, here, as the steps are like 1. The moves have, like, the first move has 1 step, second move has 2 steps, third move has 3 steps. So if there are n moves, so after n moves, the total number of steps will be n into n plus 1 by 2, right? How is that possible? Sum of, just go to Google and search sum of n natural numbers. That's how we'll get it. Okay, done. So what I will do is, I will simply do mid into mid plus 1 by 2. So I will get the distance, the position that I will reach, the pose that I will reach by having these many moves, by having mid number of moves. Okay, so if I see that this position that I found from here is greater than equal to my target, right? What did I tell? That if my target doesn't lie in the path, we have to find a number that is just greater. Okay, just greater. So I will have to find the minimum number that is just greater than our target that falls in the path, right? So what I'll do is, once I see that this position, this distance that I found from here, the position that comes through this distance is greater than equal to target, that is, our condition is satisfied. What we'll do is, we'll simply shift the search in the left section of our search area. Why? Because we need to minimize, right? So if we need to minimize the number of moves, we always have to shift to the, we always have to at least try to shift to the lower version, right? So that's what we do over here. So let's jump right into the code. Okay, so I will be taking one low limit. Okay, I will take one low limit as 1, and I will take one high limit as the target itself. Okay, that's done. Now next, what I'm going to do is, I will simply going to write the binary search code. Okay, if you've not already watched any video regarding binary search, you can try out some very simple questions regarding that, so to get a better understanding of this concept in this video. So first of all, as I said, I will try the mid. Okay, I will calculate the mid. So I will basically do low plus high divided by 2, right? And let's take this as long. Okay, since this thing, the long distance that we're going to calculate, right? As I told you, the distance is going to be mid into mid plus 1 by 2, right? So this might overflow because we are doing a multiplication, and as you can see here, the constraint is basically that the target can be up to 10 to the power 9. But if like two numbers occurs, like 10 to the power 8 and 10 to the power 9, so if that occurs, if that happens, it would obviously go above the range of the integer, right? So that's what happens here. So that's why we take long. Okay, we do mid into mid plus 1 divided by 2 again. Okay, so that's what we did. So our position, what would be our position now? Our position would exactly be equal to dist, right? So we check if our position, okay, let's just not take this over here, let's just directly test it with dist. Okay, if our distance, that is position that is reached, if that is greater than equal to target, that is our condition is successful. In that case, what we do is we store that position. Okay, we simply store that position is equal to dist. Okay, and we, as I told you, we shift our search space to the left section, okay, in order to try to minimize this specific number of moves. And if it is like dist is less than target, right, so we obviously need to increase our search space, we need to increase our number of moves. Okay, that is done. So fine. So once we are done with the search, once we have found the number, now in this, the pose is going to store the number that is going to be like just greater than the target that we have been given, that falls in the path. Okay, like 1 2, like the difference of 1 in the first move and then second move, like this, the path that we designed, right? So the number that falls in this path and is just greater than the target is going to be stored here. Now what if the number stays in the path itself? If the number is something, the example that I gave us 3, right? If the number is 3, so it falls in the path itself. In that case also, this pose will again store, because we have done this distance is greater than equal to target, right? So even if this distance is equal to target, we are going to store this specific distance only in pose. Okay, so now we assume that this distance is more than 0, like this thing does not lie in the path. So in that case also, what we do is we simply, as I told you, we simply find the difference, right, of pose minus target, right? After finding the difference, we have to check if difference is odd or even. So as you can see, if it is even, we don't need to add any additional steps, so we'll just skip that. If it is odd, we are going to check it. Okay, so if difference is odd, okay, this is just some fancy way of writing this. You can also do something like diff modulo 2 is not equal to 0, right? That is also a condition for odd. So if difference is odd, again we have two specific conditions over here, right? If last move number of steps is odd or even. So if last move number of steps, now in order to store that, okay, again we'll take one more variable over here, that is min steps. In min steps, we are going to store this mid, because this distance that we stored, this pose that we stored, is basically a result of the mid moves that we had made, right? So we'll check if this mid, right, this min steps, if this min steps, or we can say this min moves, okay, rather min moves, or let's say this is just min steps only. Okay, it's just the same thing, because moves is equal to steps in this question, so it's min steps. If this is odd, okay, if this is odd, we have seen that we have to add 2 additional steps, right? I've explained to you why we do that. If you don't remember, you can go and watch that in the previous part of the video. Else we have to add only 1 additional step, right? And at last we simply return min steps. So like if difference is even, if difference is not odd, it won't even go into this if statement, it would simply return min steps. That is the same. Okay, done. And even if it is going to be 0, if the diff is 0, that is the number lies in the path itself, in that case also it won't go into this, because 0 is an even number, right? So it will simply return min steps. So now let's run this code and check. So as you can see, this gives the correct answer. Okay, just for safety, we also do this as long, this low and high. Why to leave it? So, and this difference also has long log. Like just for precautionary measure, you can just try doing this in coding tests so that you don't get unnecessary errors. Okay, so again, the case that I told you, that is for negative target. You need to make it absolute value of the target, okay, and it will be the same result basically. So let's submit it. So this gives a correct answer. So let's look at the flowchart again. We simply have the target, okay. We check if the target lies in the path itself. If it lies in the path, like one difference, like 2 steps, 3 steps, if it lies in this path, we don't have to do any additional steps for sure. If target does not lie in the path, we will move towards the right, okay. We will only move towards the right. We will not move towards the left. Note this down. We'll start from 0, we will move towards the right, we'll move in one step, 2 step, 3 steps, until we find the number that is just greater than the target that has been given to us, okay. So if pause is the number that we reach to, now we'll find the difference between that position and target. If that difference in position is odd, we will simply check the number of steps that were there in the last move that we did. If it is odd, then we will take 2 number of additional steps. If it is even, we will simply take 1 number of additional step. And if that difference is even already, we don't need to take any additional steps. The proof I had shown you earlier in the video. So that's all for this question. If you've not done questions related to binary search, I would insist you to go do that. There are you can start from the scratch, and you can start visualizing how binary search can be used in very hard problems also. So if you have liked this video, do like, comment and share, and also put your suggestions for questions in the comment sections. Thank you and have a nice time.